Hello everyone. In this video, let's discuss how to write a program to find lowest common ancestor of a binary search tree. Given a binary search tree, find the lowest common ancestor node of two given nodes in the BST. According to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be descendant of itself. So let's take the example 1. In the given binary search tree, I need to find the lowest common ancestor for the node 2 and 8. So for the node 2 and 8, the lowest common ancestor is 6. So the output is 6. Let's take the second example. Here we have to find the lowest common ancestor for 2 and 4. So for 2 and 4, 2 is the lowest common ancestor. See, in the explanation, they have given that the LCA of the nodes 2 and 4 is 2. Since a node can be a descendant of itself according to the LCA definition. Let's take the third example. For the node 2 and 1, we have to find the LCA for 2 and 1. So here 2 is itself the lowest common ancestor. Now let's see the logic of the program in detail. So here I have taken a binary search tree. I need to find lowest common ancestor for 2 and 8 first. So for that, we have to write. First we have to write the base condition. If root is equal to null. Let's define the method so that it will be easy for us to call the recursive public tree node lowest or LCA. Fine. Here I am going to pass 3 arguments. Tree node root, tree node P, tree node Q. Fine. Now I have to check the base condition. The base condition is if root is equal to null, just return null, because if the tree is empty we cannot find the lowest common ancestor, so just return null. In case if root is not equal to null, let's check the condition. Just if root dot val is greater than p dot val and root dot val is greater than q dot val. So if the value which is present on the root is greater than p and q, what I have to do? The lowest common ancestor would have present on the left subtree. So for that I am going to call the left recursive call. So return LCA root dot left comma p comma q. In case if this condition is not true, I have to check the next condition, that if root dot val is less than p and root dot val is less than q. If this is the case, the LCA would have present on the right subtree. So return LCA. I am calling the recursive call root dot right comma p comma q. If it is not satisfying these two cases, then the root itself a lowest common ancestor. So what I can do, return root. That's all. This is the logic of the program. Now let me trace the code and show you. I have to find the lowest common ancestor for 2 and 8. So now root is present on the node called 100. So check the condition. Root equal to null? No, root is not equal to null. So I will go for the next condition. Check root dot val, that is 6. 6 greater than 2? Yes. And 6 greater than 8? No. So I will not go inside this if condition. Check the second case. 6 less than 2? No. So I will not go inside this if condition. Root itself a lowest common ancestor. So 6 is the lowest common ancestor. I will return the value 6. So root will be written. While printing, we will print the value from that particular node. Now I will take another example. I need to find the lowest common ancestor for 0 and 5. So the value of P is 0 and the value of Q is 5. Let's trace the code now. So here first I will be checking LCA. I will be passing the root value. Root value is 100. Fine. So root equal to null, condition becomes false. I will not go inside the first if condition. Now I will go here. Check root dot val greater than p dot val. So root dot val is 6. 6 greater than 0. Yes, 6 is greater than 0. And 6 greater than 5. Yes, 6 is also greater than 5. Which means the lowest common ancestor present on the left subtree. So I am calling the recursive call for the left subtree. So now LCA of root dot left, that is 200. Now root is pointing to the memory location called 200. Again check root equal to null. No, root is not equal to null. Check the condition. Root dot val greater than p dot val. Root dot val is 2. 2 greater than 0? Yes, 2 is greater than 0. And check 2 greater than 5? 2 is not greater than 5. So first if condition got false, go for second if condition. Check 2 less than 0. No, 2 is not less than 0. Second if condition also false, which means this root is the lowest common ancestor for the node 0 and 5. So return the root. So from this function, I will be returning the address called 200 to this function. So this will return 200 to this function, and this will return 200 to the main function where I have called this particular method. So 200 will be returned. So when I return 200, the value which is present in the node 200 is 2. So 2 is the output. Now let's implement it as a program. So first I have to give the base condition. Base condition. What I have to do? If root is equal to null, return null. Okay. After this, I have to call the recursive call for left to subtree. Recursive call for left to subtree. So what I am going to do, I have to check the condition that root dot val is greater than p dot val and root dot val is greater than q dot val. If the condition is true, I will be calling the recursive call for root dot left comma p comma q. Now let's call the right recursive call. Right. So for that I have to check one condition that if root dot val is less than p dot val and root dot val is less than q dot val. If this condition is true, I will be calling the right recursive call. We'll say root dot right comma p comma q. If it is not satisfying both the cases, I have to return root saying that this is the lowest common ancestor. That's all. Let's run the code now. Okay, there is an error. We'll check what is the error. Oh, sorry, it is not LCA. This is lowest common ancestor. The method name they have given is lowest common ancestor. Similarly, I have to change here also. Lowest common ancestor. Fine. Now let's run the code now. Okay, this L should be lowercase. Lowest and lowest. As it passes the test cases, submit the code. As it passes the test cases. That's all.